Hello, pre-calc. You'll be watching this Tuesday, and it'll be the 23rd. We're looking at case 3, graphing rational functions, and the numerator this time, the degree is going to be greater than the denominator. So let's just jump in and train by doing one. All right. Alright, hopefully you can see how this is this case, because the numerator's degree is 2, the denominator's degree is 1. The degree of the numerator is greater than the denominator. So we're going to think of doing, we usually do va-ha-ha, but this one's going to do a little different. We'll start with the ba, the vertical asymptote. Where do the eyeballs go? The eyeballs go here in the denominator. We're looking for values that we have to exclude from the domain. So x cannot equal -1. So that's where we will have an asymptote. So if I'm graphing this, x equals -1. That's no different than case 1 or case 2. Those are very strong vertical asymptotes. You cannot cross them at any time or touch them, like an electric fence. However, there's no ha in this, so it's not a va-ha-ha, it's a va-sa-sa. So SA, and that stands for slant asymptote. Who knew? Alright, so instead of having an asymptote that goes horizontally, we're going to have a slanted asymptote. We will have a vertical one, but instead of a horizontal, it's going to be slanted this way or that way. Alright, so it's going to be at a diagonal. So how do we find our slant asymptote? It is going to be a name of a line, like y equals mx plus b. And let's go and find it. The way we find it is we divide the polynomials. So I'm going to put this is my dividend inside my dividing box, and this is my divisor outside. So you should come to me knowing how to do this. Let me refresh you if you've forgotten how to divide polynomials. It works just like when you're dividing, say, you're dividing 21 by 4. So you don't have to write this down, but 4 goes into 25 times. So the first step was to divide. Then 4 times 5 is 20. Then we multiply. Then we subtract, and we get subtraction step, and then we bring down. So let's put a 0.0. So we have a 0 to bring down. 4 into 10 goes twice. And we're back to, so we did bring down, so we're back to divide. 10 divided by 4 is 8. 10 divided by 4 is 2. 2 times 4 is 8. Subtract, and we get 2. And now we've done the bring down, another 0. And we get 4 into 20 goes 5. So I show you how to do that because I need the steps, not that you're going to have to by longhand do division, but catch the steps. It was divide, multiply, subtract, and bring down. Alright, so we're going to do that with polynomials. On the divide step, you always divide the first term inside the divide, this is called the dividend. The first term inside the dividend divided by the first term outside, which is called the divisor. So x squared divided by x is what the first step is. So notice the division doesn't use the whole expression, just the first term divided by the first term. And x squared divided by x is x. So that answer goes right there above that division. And now we're down to multiply. When you multiply, you do multiply the value that you just placed in the quotient area times both expressions in the divisor. So it would be x times x and x times 1. Alright, so x times x x times x plus 1 is x squared plus x, and it goes right, lines up right under the terms in the problem. Now we're down to subtract. So we're going to subtract this whole expression from this one. So minus x squared from x squared is 0, so that is gone. But this negative sign affects this. So this is really a minus x and a minus x. So that is a minus 2x. All right. So now we're ready to do it again. So we're going to take this term and divide it by this term only. So negative 2x divided by x is negative 2. So that's what's going on in your mind. So we put the answer, connect it to the term previous with its sign. So minus 2 appears like that in the quotient or answer. Now we multiply this whole thing by negative 2. We get negative 2x and a minus 2. Alright, there's nothing more to bring down, so I'm ready to, before I do that I have to subtract. So I'm going to subtract. This negative makes this a positive. I add it to the negative 2x and that's gone. This negative and there was nothing to add or subtract it from, so we get a positive 2 as a remainder. The remainder can be written in the answer, the quotient area, by placing it over top of the divisor. So let's get rid of our steps. And we have x minus 2 plus the remainder over the divisor. What happens to this value is interesting as x gets large. Large in rational expressions is like 10. You get 2 over 10 plus 1. 2 over 11 is quite small. If it was 100, you'd have 2 over 101, which is even smaller. So in the long run, it doesn't really affect the value of the slant asymptote. In the long run, this goes to 0 and will not affect it. So we're just going to use this part, and we're going to get y equals 2x minus 2, which is a straight line. It crosses the y-axis here, and that's the y-intercept, and the slope is the coefficient unwritten in front, 1. So that tells me 1 is 1 over 1, so that tells me from this point I rise 1 and run 1, and there's my slant asymptote. Alright, so now that I've got that, I want to do some training for you on slant asymptotes. When you have a slant asymptote, and it's one of two asymptotes, we have this vertical one and this slant one, the answer is either this, where you have slash slash, and they're diagonal from one another, or you have this. Alright, so we've seen this slash slash behavior before, and it's no different with slant asymptotes. Alright, so let's see which one it is. In order to tell which one it is, let me get rid of my division. If you still need it, take a pause. And what we're going to do is just do 1 point on our sissy chart. Since we know it's either this or that, let's just do when x is 0. That's usually the easiest one to find. So when I put 0 minus 0 over 0 plus 1, I get 0 over 1, which is 0. So I know this point is on the graph. Do you see that's enough to tell me which pair of slashes we have? So that means we have this pair. It's going to grab that and that. And that is a very general sketch, but that's all I want. So with that, you have finished all the topics from this whole year. And that's the last new, semi-new topic. I think you might have not seen this one before, but perhaps you have. So we'll call it new. So this is the last new topic for this whole book. So we have covered so many topics, and of you, I am so proud. So with it all, I am asking you to carry on.